Flicker 2. Wow, veteran. I feel old now, bloody hell. All right, hello folks. Right, we're going to talk about something a little bit different now, which is all of this stuff. So, I've got lots of videos, you see. I want to show videos. Yes, it's working. Good. Okay, touch the buttons very gently. So I'm going to be talking to you about interfaces like this. Now, everything you see here is controlled by the hand. It's controlled by gesture. By the way, I will be doing a lot of this. I will be waving my hands around in the air a lot. And this is because technology today allows devices to recognize your hands and your body and your motions. And if we do it right, we can translate them into inputs for an interface, and we can respond in a way that's natural and intuitive. And I said if we do it right, which is what I'm going to be talking about. And I'm pausing to see if the next video, yes, cool. So these are controlled by gesture. They're what we call gestural interfaces. I think I'm only going to be using two bits of jargon in this whole thing, which will be gestural and spatial. Gestural means controlled by your hands. Spatial kind of comes part and parcel with it, and that means that the interface exists in 3 dimensions. It's not just on a screen, there's some kind of depth to it, which makes sense because your hands move in 3 dimensions, so if the interface is done by you waving your hands around, there's going to be a 3D element to it. And hopefully what you're seeing here in one of our demos is that it can be very natural and intuitive. It can be as easy as grabbing things and flinging them around and all of that, because we've all got hands, and we've all been learning to use them since we were babies. And so a lot of this stuff is quite natural. You wave at your friends and you point at things that interest you and you grab things and pick them up without really thinking about it consciously, which is one of the great sort of promises of interacting with digital content in this way. Now, the last time I gave this talk, I kind of got asked, so Matt, does this mean that everyone in the future will wear VR and AR headsets and we won't have screens and we'll all be doing stuff like this? And I thought, God, I hope not, because that's not the future I want. This is fantastic in the right places. So what I think we're heading for is a future where we will have more flexibility and variety of ways we can interact with digital content. Sometimes you might have AR glasses on and be doing something like this. Sometimes you'll be on your phone filling in a form, which is the right way to do that kind of thing. But in short, I think along with touch and voice and all these other modalities, for people like us, designing for what's on a screen might soon not be enough. And this is something that might be coming, well, something that we're all going to have to learn. Before I get too far into it, I better give you some creds. I've been doing this about 20 years. My background's in product design, and I mean the physical stuff rather than the digital stuff, which is really annoying that I have to explain the difference. I used to work for Lego, going way back. I used to do kids' toys. And I will answer questions on that if you like, but hopefully the stuff I do now is interesting enough. And then over the last 20 years, I've moved from the physical stuff into the digital stuff a bit more. I tend to specialize now in emerging forms of interaction, so stuff like VR and gesture. And for the last 3.5 years, that's what my team and I have been focusing on entirely at Ultraleap. So by this point, we know a thing or two, and we should be able to give you some interesting insights. Presses the button and hopes. Yes. So I work for a company called Ultraleap. It's a Bristol firm, started here. We're over by Temple Meads. There's about 200 of us, which I think makes us a scale-up rather than a startup. I'm not quite sure, but very much a technology company. We've also got an office out in the US in San Francisco. And we make 2 core forms of technology which we're bringing to market. So this one that you can see here is, and I say this with some confidence, the world's best hand tracking. Essentially a little camera, which is embedded in that VR headset there. It can see what your hands are doing in 3D space. We also have another device which delivers mid-air haptics. So what that means is when your hands are waving around in the air, it can, using some very low intensity ultrasound, it can send haptic sensations to the fingers and the palms. I'm going to be talking mostly about the hand tracking today, but I will show you a little bit of the haptics a bit later on. And that tech gets embedded into all sorts of different devices. So we've got VR and AR headsets. We're using it in touchscreens. We're even using it in some cars. And in all these cases, it translates your motions into inputs for that interface. So the result then are digital devices that see this. This is literally a raw feed from one of our cameras. It can see your hands. All the little coloured balls are the joints in your fingers and hands. It knows what you're doing. So we know their position in 3D space. We know their velocity, so where they're moving and which direction they're going. And as you can see, we know what your fingers are doing. So if you're making a gesture, we know what's going on. Now, I'm design director at Ultraleap. I was brought in to help start a UX team, make UX a thing at this company. And when I started my job 3.5 years ago, there really wasn't much of anything. We had one designer and one researcher doing a fantastic job, but struggling to have much influence in an organization that just had no concept of what this was. So I was shown this stuff and told, isn't it great? Look at what our technology can do. And I said, that's lovely, but I'm a designer. What do I do with that? What are the right gestures? What are the right interactions? How do I know if everybody can do whatever gesture it needs to be? So our mission for the last few years has been to try and start writing the rule book on what you do with your hands. And the first thing I had to get my head around was, well, why do it? It all looks fancy. Why is waving my hands around a good way to control a digital experience? So if you're using VR or AR, if you haven't done it, you've often got these controllers that you pick up, and they're a bit like gaming controllers. There's one in each hand, and they've got 3, 4, 5, maybe even 6 buttons on each. And for a lot of people, their first VR experience, and for most people, it's their first time, because it's still a bit of a niche thing, there's quite a lot to learn. And so theoretically, if you don't need those controllers and you're just using your hands, well, that could be more natural and intuitive. It can mean that people are getting into having fun in a game or getting some productivity done at work and be into it much quicker than they could otherwise. The other thing that VR in hands is really good for is it can help you better train for real-world scenarios. So we've seen a real kind of uptake in the number of our customers that are using this stuff for training. And that's for everyone from hotel staff to surgeons, and in this example, cabin crews. So this is from Lufthansa, one of our customers. This is using our tech. And these are cabin crews training for the turnaround. So when a plane lands and you get your bag and you go and rush off to the terminal, it's the short window they have to do the safety checks, sort the plane out, and get up in the air again. So once a year, all the cabin crews have to go through a training procedure to check that they know this process. And doing it in VR makes a lot more sense than finding a plane, parking it in the airport, getting everybody on it. And it lets them do other things, like they can have lots of people doing it at the same time. They can repeat it over and over. And the reason they chose to go with hands is because you're trying to memorize a kind of a physical activity, and you need to get down on your hands and knees to look under the chairs, and you need to open the luggage bins, pick up the cushion or the suitcase or whatever. So if you can do that with your real hands, that's just a lot closer to the real thing. It kind of frees you up. So I think they've got thousands of people now sort of doing this every year, and for them that shows better recall. That's become a better way to train for them. Every time I press this button, I'm not quite sure. Oh, too far. Okay. I have to make sure I get the videos working for you, otherwise you can't appreciate what we're doing. I've learned from hard experience that we need to be showing videos for this to make sense. Besides VR and AR, there are now whole new types of interfaces we can be making with the same tech. So my colleague here is showing how we modify touchscreens to make them work with gesture. So this is a standard touchscreen kiosk, still works as a touchscreen. We didn't make anything there. We've just added a tiny camera on top of it and installed a little bit of software. And now we can track your hands as you're standing in front of it. And you can probably see she's controlling that white cursor on screen. So we're tracking the position of your hands. From a design perspective, that's quite interesting because now the volume of air between her and the screen has become part of the interface. It is now 3D. It is now spatial. Where she's standing and what she's doing with her hands can be understood. It can make a difference. Now, when we started doing this, it was primarily a COVID thing. It was our customers asking us, can you make touchscreens so that people don't have to touch them? And it's still a bit of a thing. It didn't quite pan out to be the big thing we maybe thought in 2020. But what we discovered in trying to make these is that by allowing rollover states on a touchscreen, by knowing where you're pointing, we can bring the UI to life as you're navigating around. We can, add this layer of responsiveness that touchscreens don't normally have. And because your hands aren't just simple pointers, we can do 3D stuff too. So that shoe can be grabbed and picked up and turned over, and that's all something you can do on a standard touchscreen just by making this modification. So it's been this really interesting thing where we knew technically we could do it, but by starting to do the research and the design over the last few years, we've started to sort of see the product go in a direction we didn't originally expect. So that brings me to my first kind of big point today, which is I would wager most of us in this room are used to designing for 2D screens. I am too. That's what a lot of my career is. And we work with a really mature ecosystem. We know what the components are. We have touchscreen gestures. We have mature standards for accessibility. And Spatial's got none of that. It's a total mess. It's a complete Wild West when it comes to what are the right gestures and what are the right components. And essentially, that's our job. That's what me and my team are trying to do. Now, we're not the only people trying to do this. We're a little Bristol firm, and there's some big companies who you've probably heard of doing this as well, which is great. But we're trying to make our contribution to it because Ultraleap makes this technology. We want good gestural interfaces out there in the world, so it's in our interest to try and help write the rulebook, give people like you the toolkit that you need to go, and if you're asked to work on a project like this, that you have a decent starting point for it. But I want to get across that a lot of our job really is starting from scratch, and I think that's really cool. That's why I took the job. It makes for really interesting work, but we're in a world where there really isn't much to go on at this point. So what I'm going to do for the next 20 minutes or so is run you through some of what we know so far. There's still loads for us to do. We've been doing this several years. It's going to be many more years. But I think we're at a point where we know enough principles, gestures, and components to give you a bit of a crash course in what we've got. So I'm going to start with the simplest interaction we can have, which is how do I select something in this gestural world? How do I push a button? And on the left, I've got an example of one of our touchless displays demonstrated by Chris, who's a designer in our team, and on the right over here in VR. And I'm doing this so you can kind of see interaction-wise the difference between some of these setups. So this virtual hand in VR is me wearing a VR headset. It's overlaid on where my real hand is. Button's not there in real life. That's a VR thing. And I just reach out and push it directly. And if we've done it right, the button responds in the way I'd expect, and that's a lot like real life. Great, that's quite easy. On the left, it gets a little bit more complicated because Chris is a distance away from the screen. Now, he's standing about 6 inches away just to make a nice video, but he could be up to 1 meter away. So how do you push a button when it's over there on this screen? What do you do? He's showing you a kind of tap gesture that we've ended up using, this little forward motion in the air. But when people walk up to it for the first time, we see all sorts of stuff. We see people clicking down like they're going to tap a mouse. We see little fingers and elbows and all sorts of stuff. So we've ended up settling on this tap gesture, which is making any kind of forward motion we can with any finger or any part of your hand. But this interaction just keeps evolving because the more we go out and do testing, the more we run public pilots, the more variety of ways we see people coming up to this stuff. So whereas that started out as everyone pointing their index finger, over the last few years, it's just become broader and broader as we try to accommodate as much as we can on this. Once you've got your taps going, the next thing will be scrolling and swiping. This time I've got VR on the left and I've got touchless displays on the right. So over here in VR, again, it's a bit more straightforward. I've got my UI panel in 3D. I've got my carousel on it. Swiping it's a bit like swiping a touchscreen. I've just got my fingers to make contact with a component and I can kind of swipe away and we move it. Again, I'm not belittling the amount of work it took to get that feeling right, but if it's in there, it feels good, feels like something you know. Again, on the touchless displays, it's a bit harder. So I'm spinning this turntable. And we've put in this turntable component because that's a lot like something you'd be familiar with. You would look at that and go, oh yeah, I sort of get what I'm doing. Now, when you swipe on a touchscreen, because you make contact with the glass, we know which way you're swiping. So that's great. When I wave in the air, They both look exactly the same. It's hard to tell whether I'm swiping left and returning or I'm swiping right and returning. It's just a hand sort of flapping back and forth. So with this one, we've had to work really hard to try and discern user intent. You don't want to be accidentally picking up the wrong intention, swiping the wrong way or whatever. And for us, it's come down to these tiny little differences in the curl of the finger and the distance you're moving and stuff like that. So we're still working on this one. I think we've got it to a point where it's kind of reasonable, which is what you're seeing there. But a lot of our battle is trying to discern user intent as they're moving their hands in 3D space. I gesture a lot anyway with my hands. You know, you don't want me to like scratch my nose and then find out I've accidentally bought a train ticket. Getting it right is really important, which is where our user research is so vital. So that brings me to my next design principle, which is that gestures aren't these precise fixed actions that everybody has to learn and master. The more research we do, the more we're starting to find out that there's a range. These are just some of the hand shapes we see when we ask people to walk up to a touchless display and push that button. Even with everyone getting the same UI and the same tutorial, you see at least this range of different ways of doing it. So if we're going to make these gestures work for everybody, particularly if we're going to put them on a touchless screen, which might go in a public place, it has to work with all of this. It's got to be a bit generous. And when you think about it, that makes sense, because unlike a VR controller or a mouse, our hands are all a bit different. And we've got different shapes and different length fingers. We've got different mannerisms. The way I swipe is not going to be the way you swipe. And you'd be really pissed off if it worked well for me, but you're there and it's just not responding. We have to make it work for a range. So when Ultraleap defines a gesture, we're actually talking about a range of hand shapes. We're talking about a range of motions and things. And a lot of our job is trying to sort of figure out precisely what that is over most of the population. See, it gets more complicated the more I go into it. Everything I've shown you so far in VR has been a form of what we call direct interaction. So I've got this virtual hand, and I'm pushing buttons directly or swiping carousels directly. And that's one really common way of doing it. And there's another way, there's distant interaction, which is me controlling a component from a distance, obviously, as in the name. So in this case, I'm selecting these little objects from across my virtual space. And here we have to introduce a new kind of gesture. So first I need to know what I'm pointing at. And we've made it big and glaringly obvious here for you. We've got like a ray or a cursor coming out the hand. If anyone's, I'm sure at some point I'll get a question about the Apple headset. The Apple headset is doing it a bit more subtly, and that's based on the eyes, and it's got things kind of moving back and forth. But essentially, you need to know what you're pointing at. And then you need a way to select the thing. You need a way to tell it, select it on, off, toggle it, whatever it may be. Excuse me while I battle with my videos here. So that's why we introduced this kind of pinch or grab gesture. That's a way of saying, yep, select, unselect. What's interesting is that when we started out doing this kind of thing, we would design applications to be completely direct or completely distant, and we would bake it into the application right from the start. And as we've gotten better at it, we've moved to this much more sort of fluid way of defining things. Yes, where we can transition between them. So again, for us, it's all about trying to discern user intent. So there at the start, my colleague is doing it with distant interaction. We've got a cursor popping up, which we need. See what we're pointing at, and we're making pinches. And then they just move a bit closer, and as their hand gets a bit closer to the panel, we can go, oh, okay, you're doing direct interaction now. We'll just switch over to a different interaction mode. It's all seamless, and they don't even need to make any conscious choice. And that's the kind of goal for where we're trying to head to with a lot of this. If we know what people are intending, we just make it work. So now I've introduced pinches, I can go on to the next thing, which is virtual objects. So virtual object is kind of like a new class of UI component. For anyone that's not done VR or AR, it's 3D. It's a lot like a real-world object. It's got physics and gravity, and you can pick it up and chuck it and knock it over and slide it around. And in the airline example we saw earlier, virtual objects were a big part of that experience because you're picking up suitcases and torches and whatever. And when we started out designing these, we used to make them work just off a pinch. We used to tell everyone, pinch your thumb and forefinger together and pick stuff up, which was great for small things. And then when you try to do it with a table or a filing cabinet, it's really weird to kind of just pick it up with 2 fingers and have this huge thing like fly around. So this needed to get more like real life. We've ended up baking in a lot more physics to this so that now you can grab it with any fingers in any orientation. You can use 1 hand or 2 hand. And then it just responds a lot more like real life. And that means you don't really need to teach people how to use these things. If you've done it right, it just feels like real life. Apart from the fact you can't feel it, but I will be getting to that shortly. And then when you're designing these sort of 3D virtual objects, these UI components, yes, there we go. Interestingly, the design of that object starts to immediately affect the way people interact with it. So the size of the object will change how people pick them up. So if you've got a little thing here, like in the green, people always go at it with a couple of fingers. If it's a bit bigger, they'll go at it with a whole hand, like the yellow one. And if you've got a really big object, like in the pink, everyone tends to go at it with 2 hands. So we know as designers that whatever we do with these objects is going to elicit different gestures and different responses from people. You need a thing called a signifier as well. I'm probably using quite common UX terms. Hopefully people are nodding. A way to say, yes, this is an interactive component. Because if I'm in my VR land here, so here I'm at a kind of desk and I'm building this little product by putting pieces together, you'll notice as the hand gets close to it, I've got like a little white text bubble pops up. So we've got it coming to life a bit to say, yes, you can interact with me, because you won't necessarily be able to pick up everything in there. And then you also need an affordance. So that's a really common UX term, which means, of course, the way something looks will give us information about how we're supposed to use it. And the same is true for 3D objects. If there's a handle on it, I'm probably going to pick it up by the handle. If it's like a bowling ball with 3 fingers in it, 3 holes in it, you know you're going to put your fingers in the holes. And what interests me about that is, as an ex-industrial designer or product designer, I'm starting to see a lot of the lessons that people have from that start to apply to this 3D world of UX, and I like that, frankly, because it's coming from an industry that's more mature than ours, that has a lot going on. I like that those lessons are starting to apply. And generally that means that when things are physical and 3D in VR, they become more intuitive for us. We do things like raising buttons off surfaces. We do things like using little virtual objects to be grabbed and pushed around. So flat user interfaces make a bit less sense when you're using your hands. There we go. The other thing that we often have to do in VR is, because we're teleporting around a space, we need to give people a way to take menu panels and UI components and things with them. There's no button on a controller that you're hitting. So we've ended up experimenting with a lot of wearable UI. We've got panels mounted on your hands and your wrists and your forearms and things like that, which gives you kind of quick access to things as you're moving about. This is something that can only really happen in VR and AR. We've also found through a lot of testing that because you're missing the tactility of pushing a glass screen, we get a lot better response from people when we dial up the visual and the auditory feedback on interfaces. We do a lot with buttons changing colors and clicking. We get things that sort of grow and roll over. In some ways a bit less elegant sometimes, but a bit more dialed up than what we might do in a web interface. I'm also going to give a brief mention to our mid-air haptics, which is our other tech. I'll get in trouble because this is a very old, an old device now. It's now kind of like about way big, but it demonstrates what this does. So as you raise your hand over this device, it's sending those haptic sensations to your fingers. So what we start doing with that, we've been doing a lot of work in the automotive space, looking at how touchscreens in cars can distract drivers, and starting to look at how gesture can be used in cars more successfully. And in particular, the haptic feedback that we can give, which is delivered by all these little silver cubes there, can give you a bit more certainty. Because when you've got a gestural interface and you're waving your hands in the air, you've got a lot more freedom in what you do, but you sacrifice something in certainty. It's a bit harder to know if you've really pushed that button, whatever it may be. So you can see here our driver is kind of pushing buttons in midair. They're pinching to use sliders and things like that. And at each one of those stages, we're looking at different haptic sensations and different levels of intensity to give people that little buzz that lets them know, oh, yeah, cool, got it. And who knows, hopefully that may mean looking at the screen a bit less. Research is still ongoing. And I lied a bit earlier when I said that gestures aren't these fixed poses that everyone has to learn. Sometimes they can be. So we do use hand poses sometimes as a thing people have to learn. In short, they're really useful, but they're a bit like memorizing keyboard shortcuts. It is a nightmare to remember more than one, maybe two of these. So you can see here we use kind of pinches and thumbs up and things like that. And they can be super useful, but it's always stuff that people have got to be taught, which is why we also do quite a lot of work looking at learning in these spaces and onboarding. And I won't go through every one, but I just wanted to bring up a bit of a selection of the different modules that we do work with to try and say, if it's your first time using stuff with gesture, what am I doing? You know, where the hell do my hands go? What am I supposed to be doing with them? The big rule I want to get across with all of this is it's show, not tell. We've done a lot of testing with text and icons. I guarantee they do not work, at least not now. Maybe in a few years when we're a bit more used to seeing these kind of things. Everything that we do that works very well in testing is where we show some video or an animation or a cute little robot character that shows you what to do. And that's the very best way to teach people gestures. I'm almost there. Very briefly, ergonomics, human factors matters a lot more here as well, because stuff is all around me and it can be a lot more physical than it would be on a screen. I'll just give cursory mention to that. If you're going to be designing these kind of interfaces, you're going to find yourself considering much more where I position things in space and that kind of thing. And I'm going to finish just by showing you a little bit of mixed reality. So we're moving more into AR and mixed reality at the minute. Our team's doing a lot of work in that. And one of the next steps for us is to see how does a lot of what I've just been showing you in VR translate into that kind of space. So this is a little prototype from a recent design sprint. This is what our first pass of things often looks like. And here we're trying to see what gestures work like in AR. So you're going to see a cardboard box on a table. At least you will in a second. Maybe I want to point it that way. There we go. Right, my colleague is putting an egg in the box. You'll see why in a minute. On top of the cardboard box, I've got this virtual button augmented on top of a real object. Hit the button, and out comes Mr. Owl. And we're going to use a hand pose to call Mr. Owl over. He'll recognize the pose, come to the finger. And then when we drop the pose, he's off and flying. And we're going to use the other hand to control where he goes with a 3D spatial cursor. And the depth of that cursor is controlled by this really subtle back and forth movement of the hand. When we choose to drop our right hand, we're done with the flying, and we can use a hand pose again to call him over. And he's earned a little treat. There you go. It's super rough and ready, but it's an idea of what we are doing with developers and designers working together in these kind of hackathons and design sprints to try and test out these principles and these components and see how they work in real-world scenarios. That's a whistle-stop tour. I know I'm about out of time, so I'm going to about wrap up there and go to some questions, because I love talking about this stuff, as you can tell. Oh, very briefly, and I'll leave this up at the end. Everything I've told you today is publicly available on our design guidelines, docs.ultraleap.com, and I'll leave that up at the end for you. But that goes into way more detail than I could right now. So if you'd like to read more, look for that, or get in touch with me. LinkedIn's probably the best place, but Twitter, site, that's all up there as well. And I'll say thank you very much.